I just finished making this FEM mesh, and now I'm going to go back and recreate the steps. Show you how this is done. This is starting from the FreeSurfer Recon All result. So let's close this workspace. And now let's see, what do we have? FreeSurfer running under Linux. Okay, I've got, let's look under on the Windows side. On my machine, I have on my local disk, this is Windows Subsystem for Linux version 1, and this is the way it was done under Windows 10. I think it's a bit different under Windows 11. I think you'll see a little Linux penguin like this. But on mine, from my first setup, I have a WSL folder that I can see in Windows. I can see the FreeSurfer there. I can see the subjects directory. And when you run Recon All, the results go in here. And this particular folder is the one that I'm looking at now. All of these folders were created by Recon All. I added this folder called FEM, and I'll show you what it does. So all you need in here to start with is, I'm going to delete everything except for this prepare for emse.txt. This is a bash script. Let's see, it's just a small little bash script. And we're going to run this script under Linux here. So I'm in this folder on the Linux side, and I'm going to run bash prepare for emse.txt. And you can see it's copying over and making a few conversions. The folders, the files that we will need, the results we'll need on the EMSE side. Okay, so this is what we'll need. And what I'm doing here, now I made a, I'm starting pretty much from scratch to show you how this is done. I'm in a folder here called, I made a folder called FreeSurfer to FEM, and I zipped it up. I have a zipped version of that I can give you, so you can start in the same state it's in right now. It has a New York head, that's a New York head version 2. You don't need to change that. You just need to have it as a resource, and I'll tell you about that later. Then a folder, you don't have to call it KM. KM is the name of the researcher who provided this MRI. And so I used her initials, KM. You could use SS or whatever you like. And in here, you won't need the extra, but I'm going to be, there's a couple things in there I'm going to look at for reference. What you will want to do is have these scripts make a folder called FS for FreeSurfer and put under it, for each participant, put under it put a folder under that will contain the FEM. This is just a copy of the same FEM we were just looking at on the Linux side. Okay, so you can use different conventions for this. I used KM dash and then participant name. So this is for when we'll have multiple participants. And we'll end up making an EMSE workspace with multiple participants. Okay, that's the start. Now, what I'm going to do, I'm running MR Viewer. I'm running a version 6.5, which is our working version. Everything I'm showing you should also run in version 6.4. but I run 6.5 internally to test it, make sure it's running, and we are adding new features. So I will start with a new workspace and save it right away to the folder I want it to be in. There it is. It's already in that folder. Let me give a name called FS to FEM. Okay, so that gets me started. Now I'm going to want to run a script. Now, you may, if you're running this one as is, as the demo, you won't need to change anything in the script. But let me show you what you would change if when you're running your own participant. So this input folder here points to the FreeSurfer KM dash. That's this much, and then we'll add the participant ID to it. And then the subject ID, whatever your subject ID for your subject, put that in here. And that's it. That's all you would need to change. So let me go to Utilities, Run Script, and I'm going to do the first one, Head Model Before Landmark Script, this one. Okay, so MRViewer is going to import the T1 image that FreeSurfer cleaned up a bit, convert it to the VMI format, and we're also getting the FreeSurfer Cortex wireframes. I'll show you. So now this project one, I could just delete that one. Don't need that anymore. But the script created this new project with the participant's name or participant ID. There's a VMI file created from the FreeSurfer T1, and let me just expand that a bit. So here's the VMI file that came from the FreeSurfer T1, and now the Cortex was also converted in that script, and in particular we took the peel surface right and left hemisphere and the smooth white matter surface from FreeSurfer, and we averaged those two, and this is the average we're calling mid cortex, and we also merge them together. So FreeSurfer makes each hemisphere separately, and we merge the two here in EMSE. So you can look at it also in the visualizer, and FreeSurfer does a nice job on the cortex. Once again, this is the midway, it's not all the way out to the peel surface, so we can see down into the sulci. And importantly, FreeSurfer, because it makes each hemisphere separately, we have the full medial surface of each cortex, or buried, each hemisphere. They're buried down there, but we've got them. Okay, so what next? Okay, why did we stop the script here? The reason we stopped the script here, let's see, wait, I didn't mean to do that. I just want to save the workspace. Save workspace. There we go. All right. I have another. The thing that FreeSurfer does not give is the skull. And this is a T1 weighted image, and as you know, the skull, although we might imagine we can see the skull here, really we don't see the skull. And in order to get the skull, ideally you would need CT, but that's ionizing radiation. So what do we do? What we're doing here is, so here's another instance of MR Viewer. This is the New York head resource, which, as you see, I included it here, and the next script is going to use that. So, but just to show you that the New York head has a nice skull because they merged a CT and some participant that they had. They merged it into the MNI space, average head, and so therefore, because the New York head has a nice skull, our strategy here between the script 1 and script 2 is we will make some landmarks that will be used to convert or transform, make an affine transformation from the individual MRI to this space here, this New York head space. Then based on this we'll have other surfaces. So we do have, we'll have the individual scalp surface, we'll have the individual, we'll have what's called the convex hull of the brain. We'll have other surfaces that we can see in the individual, and then we have all those same surfaces here in the New York head. Essentially, our algorithm is going to interpolate the skull between known surfaces, and that's how we get the skull in EMSE, and FreeSurfer by itself doesn't do that very well, at least. Okay, so what do we need? So now I'm going to mark some points here as landmarks, and I put some extras just so I could refresh my own memory on what these points are and what I want to call them. So I'm going to put these on the other screen, but basically I'm going to, and you don't need to mark these in any particular order, but you do need to give them the labels that are expected here. Some of them are, so we'll see what these are. Left eye, the center of the left eye, center of the right eye, Bayesian, anterior extent of the corpus callosum, posterior extent of the corpus callosum, an inferior notch of the pons, a superior notch of the pons, a superior extent of the brain on the midline, a posterior extent of the brain on the midline, and right ear and left ear. These are not the preauricular points, but as you'll see, I'm going to mark the center of the auditory canal as it exits. So these are going to get us oriented, and you don't need this file. Actually, EMSE is going to create it, but I'm using it as kind of a cheat sheet. Okay, so what am I going to do here? I'm going to go. Let's start with the left eye. Now, MR View, as you know, uses this radiological convention. So I've got this warp to point set. Let's go here to the center of the left eye. Get it in all three views. Okay, that's good enough. And I'm going to right click in this here, left mouse action, set registration point. Now I want a labeled point, and I'll click in any of these right at the center of the crosshairs. Click, and I'm going to give it the name left eye. Okay, so this label does matter because EMSE is going to expect to find certain labels. There's left eye. Okay, now let me go back to this, this one, warp to point, and let's go to the right eye. Make sure it's centered in all three views. That's good enough. Okay, now I'm going to right click, left mouse, set registration point there. And I'll call this right eye. Okay. All right. What's next on my cheat sheet here? Let's do the Bayesian next. Okay. That's straightforward. Okay. I always need to go back to this one. Otherwise, now we're in the click mode, the add point mode. But I'm going to go back to the warp to point mode here. Let's look for the Bayesian. Okay. Okay, that looks pretty good. I sometimes also use this navigator here that's pretty good. Okay, so now I'm going to mark that as the Bayesian. Left mouse, set reg point, click, and we'll call it Bayesian. All right. Next, I'm going to mark the anterior extent of the corpus callosum and then the posterior extent of the corpus callosum, which I'll show you what I mean by that. Make sure I'm in warp to point mode. Okay, there's a good first approximation there. Actually, I just want to make sure I'm on the midline, and that looks pretty good there, although I could tweak it here with the coronal. That's probably a tad bit better. Okay, that's good. Now let's right click, left mouse action, set registration point. And I want to call it ANT capital CC. Right. Okay. Back to warp to point mode. Let's go back here. Now this participants, as you can see, they're tilted. This is not necessarily your typical orientation for an MRI. But basically I'm going to be sort of mentally thinking of this axis here, and I'm going to mark it back here, and let's see, let's adjust the sagittal. I'm using the navigator now to adjust the sagittal to the midline. Is that right? Yeah. And that looks pretty good, so I'm going to right click, set reg point there, and this is going to be POSTCC. All right, now let's see, back to the list. So now let's do, and you don't have to put them in this order. As I mentioned before, I just wanted to make that clear. But the thing that you do need to get for EMSE to recognize these names. So I'm going to do inferior and superior pons. I call the notch. A neuroanatomist might not call it that, but let's look. What I'm aiming for is like something like that as the superior notch. Let's see. Let's move the sagittal in that way a little bit, and that's what I would call the superior SUP pons. Left mouse action, set reg, and I'll call this SUP PONS, superior pons. Okay, back here. Now, the inferior, the little notch is down here, and Okay, so I'm going to right click that and left click the crosshairs and call it I and F ponds. Inferior ponds. Okay? Alright, now what? These two, the next two are a little less well defined compared to the ones we've done so far. And I should add, they aren't terribly critical because when EMSE does the transformation to the New York head, it's not going to use only these points. It's going to use the envelope of the brain between the two also to make the transformation. So these can be a bit on the proximate side, but basically it's telling EMSE to get the right way to get the axes oriented to begin with. So let's start with this one called superior brain. I'll show you what I mean by that. Let's make sure we're in warp to point mode. I mean, to a first approximation, it's up here. But in this head, because it's tilted, really it's more here. You know, it's like where the vertex would be, roughly speaking. More like this. And we want it to be on the midline and on the brain surface, not undura-modern, but something more like that. And that'll be good enough. So I'm going to right click there and put our SUP brain there. Now we're going to do a posterior brain, because basically what we're doing, we're putting points superior, inferior, right, left, and anterior, posterior. We need a few more anterior, posterior, one more at least, that's going to help us in that. So I've already done warp to point. Let's go back here again. I'm looking kind of along this line, and that's probably about right. So once again, we're trying to define this major axis, and let's call it POST brain. Okay, now there are just two more, and these I'm calling right ear and left ear. They aren't the preauricular points that would also be used for registration purposes, for electrode registration. But these are more like the eyes. We want to sort of get in the middle of the auditory canal at the point of exit. And there's going to be a little judgment there, but once again, this is not going to be totally critical because, as I mentioned, EMSE's not using just these points to do the affine transformation. Okay, so we want to get one right ear and left ear. Let's go make sure we've got warp to point mode. Right ear here. Yeah, that's kind of what I'm aiming for, is the middle of the auditory canal. But what I do, let's see, sagittal, let's move it out so that I don't, so I'm only seeing one hole instead of what I mean by that. Let's if I go inside. Now I'm seeing like two compartments of the ear there. I'm moving out as far as at least, so I'm just seeing one. Centering it there, and it's roughly where the point of exit. So let's mark this one. Set registration point. Click, and this is on the right side of the radiologist convention, right ear. Okay, back to warp to point mode, and let's do the same thing on the left. That's not bad. So let's right click, set registration point, and left click, and this is going to be left ear. Okay, so now back here, back to this warp to point mode. Now we've marked these 11 points, which will be used to give EMSE a nice orientation for orienting the affine transformation to the New York head. And notice we have an asterisk here, so that means these points can now be saved to the VMI file. So let's right click here and just say save. Overwrite? Yes. So now these points are now saved in the VMI file. Okay, what else do we need? We need a couple of bounding boxes. I can close this one now. We'll need one for the brain and one for the head. So let's go to Edit, Segmentation, and there's a bounding box tab here. You may have used it before. So just a click and drag. Let's do the brain first. Get the whole brain. So I want to make sure I get the whole brain in here. We've already segmented the brain, but this is needed for some subsequent steps. So now just want to make sure I'm capturing the brain. Okay, and let's make sure here. Yep, you've done this before, I'm pretty sure, this sort of thing. So now I'm just going to look through all the axials and make sure I'm not cutting off the brain. And that looks good. The other thing we're doing here is we're cutting off, this is also going to be used, to cut off the bottom side of the brain. Because we're a head model, we're not going to include everything down here. For one thing, different MRIs include more or less of the neck. We're just going to go make sure we're cutting off down here somewhere. Okay, so now I need to save that bounding box. So I'll say save. And now we have a naming convention we want to use. I have one here. We want to call it BB underscore brain. Okay, that's just for my... no, we're not in the FreeSurfer anymore. So we're now in this P139 under VMI. So EMSE created these things. Now, here's where in the VMI folder we want to create this BB, capital BB underscore brain lowercase. And it'll get the extension box. So I'll just say save. Okay, now let's expand this and to the whole head. So let's make sure now we're getting the head. Let's make sure we extend it farther down than we did for the brain. There we can get, and let's see if that works with the sliding through the axials. Okay, that looks to me like it's working. So now I'll save this one, and I'll call it head this time, BB underscore head. And save. Okay, and we're done with that. Okay, so now we've done the manual stuff that we need. And now comes the next step, which takes a bit longer because this is going to be extracting the scalp. But let me show you the script we're going to run. Is this number 2 script, head model after bounding box and landmark script. And just show you if there's anything you would need to change. If you've changed the place where you put your FreeSurfer results, that would be changed here. This is the subject ID where you change that. All this other stuff might be tweaked, but I would leave it alone for now. And also this tells where to get the New York head resource. And the way I have it set up now, this is correct. It'll find the New York head resource in this relative path. So we're ready now to run that script. So I'll say edit, load script, and make sure I'm there. Number 2. Okay, this one might take a little while. So while this is processing, I might just describe a little bit what it's doing. So it says make convex hull using shrink wrap. So we're taking all the brain, including cerebrospinal fluid, all and white matter, gray matter, and making basically an envelope around it, but one that's convex, that doesn't have any indentations. And then we're going to use that one because we have the same thing going back to the New York head. We have the same thing there. So let's see what we have. The New York head, we have the convex hull is this on the New York head. See how it goes like this. And actually, we make the convex hull on the individual. And this one is actually the major thing we're using to create the affine transformation between the individual and the New York head. The other thing we have with the New York head, let's see, what do we have? We have an inner skull. So I don't know if we can see that. We have an outer skull. Maybe I need to unload this to see that. So inner skull, outer skull. Oh, yeah, it might be not displayed. For some reason I'm not seeing it, but we definitely have those surfaces, although I'm not seeing them at the moment. And of course the main thing is we have the scalp, and essentially we're going to interpolate between. It's a little bit more complicated than just simple interpolation, because you can see sometimes the convex hull goes beyond. But essentially we're going to interpolate proportionately between these two known surfaces and the individual. Anyhow, when that process completes, you'll get these regions attached, and you'll get some other wireframes. The FEM you don't have yet. I'll show you basically what I did to get the FEM. So when the process completes, make sure to do a save workspace just to make sure everything gets saved. And now underneath the VMI file we have these regions which were created by the last step. So let's look at them. We've got the skull, which is the main one that we were trying to get. And notice that the skull now is not a fixed thickness everywhere. It varies. One of the approaches that EMSE used to take was to make a fixed thickness, but also you get cheekbones, you should get eye sockets here. And all that, of course, came from the by interpolate in this one over here, the New York head. Okay, let's see. Then we also have scalp, and we have CSF, gray matter, and white matter. Okay, so once we load these, we're now ready to make our FEM mesh, which I'll just show you what I did. So wizards, mesh generation, 3D mesh FEM. These are loaded. I used a decimation factor of 4, and I changed this threshold to 32. I think we should start defaulting to that. If you look at the help, it tells you the recommendation, and so I used 32, and then I just say next, and it gets started, and when it's done, and you save it, MR Viewer will notice that we don't have a registration yet, because actually we don't have electrodes yet, which is fine. You just say save anyway. And when it's saved, the mesh will be saved in the voxel coordinates of the image. And that's good because we will later register the electrodes to this mesh. That means we won't have to recreate the mesh if we have a different set of electrodes at, say, a different point of time. So that's it. Just to recap, so FreeSurfer didn't really do the full work we need for an FEM because we need to get the skull out of it. And it's a T1 image, and we used the technique of transforming to the New York headspace and essentially interpolating between the convex hull of the brain and the scalp. Okay, the other advantage of that, which I may have already mentioned, is that we have now transformations available. I'll show you where they are. So under VMI we have this STD folder. We now have we have two matrices, an affine transformation matrix, which will take us from the individual to the standard space, which is essentially M&I space, and the other way around. We can go from M&I space to the individual. So we get that for free based on this particular method. Okay, so I'll stop here. The next step would be we would want to register electrodes, and we would want to then make a forward operator. So there are a few other steps.